So this is National Instruments Multisim software package. Multisim is an electrical and electronic design simulation package. It allows us to simulate all kinds of interesting electronic circuits. So we want to create a new design here. So we can go over here, and here's our drawing space. So we want to do something fairly simple here. So let's grab a DC power source. So this is basically just a battery, and we need a ground connection. And then let's do something, like I say, fairly basic. So let's just use two resistors connected in series. Okay. Now this is what we call a schematic representation of an electronic circuit. So an electronic circuit doesn't look like this in real life, but this is how we would draw out a schematic circuit, or draw out an electronic circuit on paper. Now, if you want to know what it looks like in real life, we do have an option here under Tools called View Breadboard. And when we create electronic circuits, we frequently build them on these. When we're prototyping, anyhow, we'll build them on these what we call proto boards or breadboards. So here's my battery. So that looks like a AA battery, right? And I can put it over here on the breadboard. You can see it turns green when I get it in a particular spot. And then here's my resistor, and that is a 2.2 k ohm resistor. It's even the colors on the resistor are correct for that color, that size. And then once I place it on the breadboard, I can go over here and wire everything up. So I can't see that very well, so I'm going to zoom in. I'm going to wheel in with my mouse, and then I'm going to go over here and wire this thing up. And you'll notice that it'll actually show me, where I'm connecting. So I want to connect that to over here. So you see that's already lit up green. So that wire is supposed to go over here. And I don't really like how I put that wire, so I'm going to just click on it, and then I can delete it. And I can do that again. So I'm going to put it there, and see how that's turned green. Now over here, I'm going to grab this side of the battery, and oh look, great, that's where my wire is supposed to be connected to. Great. So let's just look at that with this particular guy. So if I click on that wire and delete it, and then I click on it again, see, there's where it's supposed to go. So there's where the wire is connected. This is where it's supposed to connect. Boom, done. So now that is how it should be wired up in real life. And I can actually rotate the breadboard so I can get a different view of it, and spin it around and do whatever I got to do to make myself nauseous. And that's it. Now, if I go back to here, this is just highlighted to show me that that the breadboard design has been complete and it's all correct. I can grab a multimeter, and I can say, okay, well, I want to measure voltage. So let's take this multimeter, this digital multimeter, and I'll go click and click. And so I'm measuring the source voltage. I open up the meter, so I select voltage, select DC, run the simulation, and I measure 12 volts. And that's great. Now, if the student were asked to measure the total current, often they make a fatal mistake, and they just go click and switch it over to current. Now the problem is, if this was a real circuit, you would have just blown the fuse in your meter, and that's not a fun thing. In this case, the meter just kind of freaks out and say, hey, there's an error, something's clearly wrong here, and so it gives you this error result. Now if I stop it, stop the simulation, disconnect it, and then I can go there and insert my meter. Oops. And do that. Now the meter is connected properly to measure current, run the simulation, and there's my current. So that's good. Now, of course, that meter doesn't look like a real meter. If I had a real bench meter. So let's get rid of that one. And I'm going to stop the simulation, which I always forget. And then we go to Simulate and Instruments, and then here's the ones that come with Multisim that just look like Like for example, there's an oscilloscope. So that's very, very kind of simple and straightforward with all the stuff. But I also have these instruments. So for example, the Agilent multimeter. So Agilent is a test instrumentation company. They make real multimeters. And if I open that up, oh my goodness, that looks like exactly the same meter that I have in my lab. For example, if I want to measure current in this case, so that's this guy over here and this guy. So I can connect onto there and hook up to that resistor, and then it shows me that I've connected to that spot on the multimeter. And let's say that I goof up and I connect my wire over here. And then, oh, see, I put it in the wrong spot. So I can delete that and then move it over to the right one, and it shows up. Now if I want to measure the current, I start the simulation, and you'll notice nothing happens because this is like a real digital multimeter. So I got to press the power button, turn on the power, and I want to measure DC voltage. So I got to go shift, and DCI is DC current, and then there you go, 2.7 milliamps, same as the other meter. So it's measuring it correctly. We've also got other instruments in here. We've got an Agilent oscilloscope, for example. So this is just like a real oscilloscope. This is an older model, as you can tell by the floppy disk drive there. But I have this exact same or very similar model in my lab that I use. We also have from other vendors. There's one here from Tektronix, for example. Right? So there's a Tektronix oscilloscope. So you've got these front ends that look exactly the same as the real thing. So you can make mistakes here, and make your measurements and make mistakes, and it's not fatal, right? Nothing happens. The computer doesn't explode or anything. So the students can test things out and try things out in a very safe environment. Now in the next video, I'll show you how we start to blur a pure simulation into something that's much more real. And I'll see you in the next video.